Hi everyone, I'm putting together a series of worked problems in Calculus 3. So if you're a student interested in learning Calculus 3, this video is made for you. So in this video, I'm going to be walking you through some problems on dot and cross products. So without further ado, let's dive into the video for today. First of all, let's talk about the definition of the dot product of two vectors and the definition of the cross product of two vectors. So imagine we are given vector A to be a1i plus a2j then plus a3k, and I'm also given vector b to be equals to b1i plus b2j plus b3k. Okay, and I can write this using the angular brackets notation, which is just given by the components. So I'll just write the components a1, a2, and a3. And this can also be written as b1, b2, and b3. So anytime you see this notation, so this notation can also be written as this. And then, if we have our coordinate system, let's say this is the x component, this is the y component, and this is the z component. So we said I is the unit vector in the x component, j is the unit vector in the y component, and then k is the unit vector in the z component. Now, the dot product of two vectors, so let's say we have vector A to be this, and we have vector B to be this. And then let's say the angle between them is theta. So anytime we are saying the dot product of A and B, so the dot product of A and B is just the amount of vector A in the direction of B, or the amount of vector B in direction of vector A. So that's literally the idea behind the dot product of two vectors. And this is a scalar quantity. So there are a couple of ways in which we can use to calculate the dot product. The first way is to just multiply A1 and B1, then you add it with A2 and B2, then you add it with A3 and B3, and that's why we have this here. Or you could just take the magnitude of A, multiply by the magnitude of B, then multiply by the angle between the two vectors. So that's the idea behind the dot product. And how about cross product? So cross product is saying that, let's say I have a vector A and I have vector, let's say this is my vector A and this is my vector B. So the cross product of vector A and vector B is given by this expression. So basically you have the determinant of ijk as your first role. Then you have the component of A as the second role and the component of B as the third role. So you also have to take note that cross product of A and B is not the same thing as cross product of B and A. So basically this comes from the idea behind the properties of determinants. So basically the cross product of A and B is same thing as negative of the cross product of B and A. So I just want to take note of that. So what is the physical interpretation of cross product? Basically, when you take the cross product of two vectors, basically you're trying to calculate the vector that is perpendicular to both A and B. So that's the idea behind the cross product of two vectors. Now that we have the idea behind the cross product and dot product, so let's look at some examples on that. So the first example here is that we are given A to be of components I plus 2j plus k, and we have this component B to be of negative component negative 1, 0, and 3, and we have C to be given as 4i minus 2j and plus k. So we have to compute the following. So first thing is that we want to compute A dot B. So again, remember that if we are given two vectors and we know the components, the dot product of two vectors, right? So we have B to be of components minus 1, 0, and 3. And then we have C to be of components 4, minus 2, and 1. So the dot product of
these two vectors is given by, so basically we take -1, we multiply it by 4, then we add it with 0 multiplied by 2, then we add it to 3 multiplied by 1. So if we simplify this, we have this to be -4 plus 0, then plus 3, which is -1. So you can see that when you take the dot product of two vectors, you have a scalar. So dot product is a scalar operation. Okay, so another thing we can do here is that, so here we are asked to calculate 2 multiplied by a, we are asked to scale a by 2, then we subtract, then we compute 2a minus c. So the first thing here you want to do is that you're given a to be of components 1, 2, and 1. So 2a means you need to multiply each of the components by 2, which is just 2, 4, and 2. And then you have c, which is given as 4 minus 2 and 1. So if you are to calculate 2a minus c, so all you have to do is just to say fine. I'm just going to do 2 minus 4, then 4 minus 2, and then 2 minus 1. Okay, so what you're doing is that you're trying to you just want to subtract it from each of the components. Just want to do components wise. So you subtract one component from the other according to the expression you're given here. Okay, so and then if we simplify this, what are we supposed to have? So we would have this to be -2, 6, and 1. So this is 2a minus b. And then the last, okay, so let's do c. So c is more or less like, if you have a, first of all, we need to calculate a minus c. So a minus c is given by, so we have a minus c, so which is, so a component a is given as 1, 2, and 1, minus c, which is 4 minus 2 and 1. So if we subtract these components from one another, we have this to be 1 minus 3, then this is 2 minus 2 rather, because we have this to be -2, and then we have the last one to be 1, component 1 minus 1, and then we're going to have this to be -2, 4, and 0. But then we are asked to calculate, what does this sign mean? This sign means magnitude. So basically, the magnitude of a vector is its length. So basically, if you have a vector component, let's say vector component A. So the magnitude of A is just the length of this vector. And how do we calculate the length of a vector? Or let's say the magnitude of a vector. So here, this is just basically this. So you have to square the components. So let's say we have this to be a1 square plus a2 square, then plus a3 square. Then you add them up, then you take the square root of the resulting results. So basically, so how do we find the magnitude? So basically, the magnitude of a minus b, or minus c rather, is going to be square root of -2 square plus 4 square plus 0 square. So you end up having this to be square root of 16 plus 4, or let's say 4 plus 16, which is square root of 20, or you can write this as 2 square root of 5. And now the last expression here, we have to calculate the cross product of A and C. So again, to calculate the cross product of A and C, so you have your first rule to be the I, J, and K components. Then you have your second rule to be the components of this first expression over here, or the first vector over here. And the last component, which is the third component, will be the components of this vector over here. So let's do that. So the cross product of A and B, so the cross product of vector A and C is given by, you arrange I, j, and k. And then the second row will contain vector A, which is 1, 2, and 1. Then vector C would contain the component of C, which is 4, minus 2, and 1. So the next thing is to just find the determinant of this matrix. So we want to calculate the determinant of this matrix. So if you don't know how to calculate the determinant of 3 by 3 matrix, just Google it, how to calculate the determinant of 3 by 3 matrix, and you will know how to do it. Okay, so let's just go ahead and calculate the determinant. So to calculate the determinant of this 3 by 3 matrix, so we start by saying, we pick the first component here, which is I. So we say this is I. So this is equals to I. Then you take the determinant, so meaning that if you cover this and you cover this, so you are left with these 4 elements. 2, 1, minus 2, and 1. And then you take, so this is j, right? So you have j. So instead of having ordinary j, so this is going to be minus j. So again, I encourage you to check how to calculate the determinant of 3 by 3 matrix. It's quite straightforward. So basically, we just take this to be minus j because this has, so this is plus, minus, and plus. So we take this as minus j instead of just plus j. So we take this to be minus j. And then we go ahead and cover this and we cover this. So we are left with 1 and 1, 4 and 1. So we have this to be the determinant of 1 and 1. Then we have this to be 4 and 1. And then this is going to be plus k of, so meaning that you cover this and you cover this. So that means we have 1, 2, 4 minus 2. 1, 2, 4 minus 2. And then so we go ahead and calculate the determinant of this 2 by 2 matrix. So which is high to be 2 times 1, which is 2. And then 2 minus 2 times 1 is minus 2. Multiplied by minus, we have plus 2. Then minus j multiplied by, this is 1 times 1, which is 1. Then 4 times 1 is 4. Then we multiply by minus, we have minus 4. And then plus k multiplied by 1 times minus 2 is minus 2. Then 4 times 2 is 8. Then we multiply by minus. This is going to be minus 8. And then we end up having this to be 4i. So 1 minus 4 is minus 3. Minus 3 multiplied by minus is plus 3, plus 3j. And then you have this to be minus 10k. So minus 10k. So you can see here that the cross product of two vectors is also a vector. All right, I hope you understand that. Okay, so let's move on to the next question. So the next question is that we want to find the unit vector in the opposite direction of the vector, of this given vector over here. So basically, we want to calculate the unit vector in opposite direction. So basically, if you want to calculate the unit vector of a vector, basically the unit vector of a vector, for example, if I give you a vector v, and I ask you to calculate the unit vector, all you have to do is just to normalize the vector. So how do you normalize the vector? Basically, you pick the vector, then you divide it by the magnitude of that vector. Then you get the unit vector. So the unit vector of a vector, which is denoted by just v hat, is the vector divided by the magnitude of that vector. So basically, you want to ensure that the length of this vector is 1. You want to ensure that the length of your unit vector is 1. So that's the meaning of unit vector. Unit vector is a vector that has magnitude of 1. All right. So meaning that if you are asked to calculate the unit vector in opposite direction, first of all, vector in opposite direction, so let's say u, is going to be minus v. So meaning that if you are going in this direction, let's say this is positive, opposite direction is going to be negative. So basically you want to multiply your vector by minus to show that you are going in the opposite direction. So now since we are interested in finding the unit vector that is in the opposite direction, so meaning that the unit vector, or let's say the vector opposite in this direction should be minus of v, so which is just minus 4, 1, and 2. And if you multiply this out, you're going to have this to be 4, minus 1, and minus 2. So this is the vector in opposite direction. Now, how about the unit vector of this vector? So we denote this by u hat, which is just your vector divided by the magnitude of your vector. Okay, so which is just your vector, which is 4, minus 1, and minus 2, divided by the magnitude of your vector. So which is just the square root of 4 square plus 1 plus minus 1 square, then plus minus 2 square. Okay, then this is going to be 4 minus 1 and minus 2 divided by square root of 16 plus 1, then plus 4. So here we have this to be 16 plus 4 is 20, then plus 1 is 21. So we have this to be 1 divided by square root of 21 multiplied by 4 minus 1 and minus 2. So basically the magnitude of this your unit vector must be what? Must be 1, because we already normalize it by the magnitude. So basically by the time you take the magnitude of this vector, it's just going to give you square root of 21. And then square root of 21 divided by square root of 21 is going to be 1. So that's why the magnitude of every unit vector is always 1. I hope you find this video very useful. If you're enjoying this video, why don't you just click on the subscribe button or you click on the like button. All right, thank you. So let's move on to the last question for today. So in this question, we want to learn how to calculate the angle between two vectors. So imagine if we are given two vectors. Let's say this is vector u and this is vector v. And we want to calculate the angle between them. Now you recall when I defined the dot product of two vectors. Remember that I defined the dot product of two vectors to be, so let me scroll back up to show you the definition of the dot product of two vectors. Basically the magnitude of the two vectors multiplied by the cosine of angle between them. So now, meaning that if I want to calculate the angle between two vectors, so I want to recall the definition of dot product. So the dot product of u and v is given by the magnitude of u multiplied by the magnitude of v multiplied by the cosine of the angle between them. And then I know how to, so I can just rewrite this because I'm looking for the angle between them. So I can write this as cos theta, which is just going to be the dot product of two vectors divided by the magnitude of u multiplied by the magnitude of v. And now I know how to calculate the dot product of two vectors since I'm given in terms of the component, in terms of the component wise. Okay, so u dot v is given by, so here I have this my u to be components minus 1, 0, and 3, since the j component is not, since the y component is not present. And then v is given by 3, 2, and 1. Okay, so meaning that if I should take the dot product, I'm just going to have this to be minus 1 multiplied by 3 plus 0 multiplied by 2, then plus 3 multiplied by 1. And then if I simplify this, I will have this to be minus 3 plus 0 plus 3, which is simply 0. And then what is the magnitude of u? Magnitude of u is given by the square root of minus 1 square plus 0 square, then plus 3 square. And then the magnitude of v is square root of 3 square plus 2 square, and then this is plus 1 square. Then if I simplify this, I'm going to have this to be 1 plus 0 plus 9, which is square root of 10. And then this is square root of 9 plus 4 plus 1, which is square root of 14. So meaning that I have this to be cosine. This is going to be 0 divided by square root of 10 multiplied by square root of 14. And then I have this to be cosine of theta to be equals to 0, because 0 divided by any constant aside from 0 is 0. So fortunately I have this to be 0, so meaning that my theta should be arc cos of 0. So I can just rewrite this as arc cos cosine of 0. And what is the arc cosine of 0? So the arc cosine of 0 is pi over 2. So we have this, so we have the angle between them to be pi over 2. So meaning that for this problem, we have the angle between the two vectors to be pi over 2, which is just 90 degrees. So we have it to be at right angle. So we have these two vectors to be perpendicular to each other. Why? Because the angle between them is 90. So meaning that two vectors are said to be perpendicular, right? Or let's say is said to be at right angle to one another. Or let's just say two vectors are said to be orthogonal if the dot product of the two vectors is 0. So if the dot product of two vectors is 0, then they are orthogonal to each other. All right. Thank you so much for watching this video. If you find this video useful, don't forget to click on the subscribe button so you will be the first to be notified whenever I upload a video like this. Thank you.